evening, everybody. Welcome to Subnetting Night. Hey, Big Papa, good to see you. Thanks for saying hey. Be sure to chime into chat to say hi. We're going to have some fun tonight. You can see the agenda's pretty straightforward. We're simply just going over subnetting tonight, so it should be a lot of fun. Hey, Gus, good to see you. Thanks for coming by. It's been a while. I'm glad you're here. Hey, so yeah, we are, believe it or not, we're not quite to a month yet. We're really close to a month out from Cisco's Apocalypse. February 24th is when the new CCNA goes live, when everything changes. So just be ready for that. If you're working on your CCNA, the PSA of the night is to make sure that you are going really to start taking that test within the next week or two, because you want to make sure you've got time in case of a fail report that you can go back and get it going again. I see birthday wishes coming in. Hey, thanks guys. Appreciate that. Yeah, it is my birthday, and I would, living in Michigan, where it's, we've got, I don't know how many inches of snow out there, and it's not like I'm going anywhere tonight. So I was like, hey, you know what? Let's just keep the stream going. It happened to land on a Tuesday this year, and hey, I love this. It's a lot of fun, and so, why not? So got to spend a lot of time with the family today. We're good. They're all relaxing. In fact, one of my kids is sick, so unfortunately, we'll see if we can hang on and not circulate that illness here moving forward. So hey, Julio, thanks for coming in. Happy thank you very much. Thanks for the birthday wishes, everybody. All right, so tonight, subnetting. I threw a couple of points on there that we're going to cover: binary conversions, magic number. Ultimately with subnetting, everybody's got a different way of teaching subnetting. For those who have seen, for example, Jeremy Chara, Keith Barker, the CBT Nuggets courses that they teach one way, I teach another way. Really, it's all kind of the same way. It's just different ways of looking at it and thinking about it at times, because ultimately it's taking binary math and trying to do things with binary. And if you as you explore subnetting, you just need to find what works for you. So I've said before, as I've taught subnetting, I'll say it again, there isn't going to be one technique that is going to work for everybody. So if this works for you, great, add it to your repertoire. If it doesn't work for you, then, write it off. And that's all good. So in fact, I highly advise going out and watching some of the other videos, especially if you have access to CBT Nuggets library, see what else, how everybody does it, just to give you that well-rounded view of what's happening from a binary perspective, to see what's going on underneath the hood. So Big Papa, 1 week from today. All right. By the time you get to the review, next week we're doing a review. So that's going to come 1 week too late for you. Yeah, we'll be celebrating with you. Hey, when you pass, be sure to join and tell us you passed. Don't just be like, I don't need that. So at least for 5 minutes, just join and be like, hey guys, I'm good. I'm out. Very good. So if anybody else is planning to take the CCNA before February 24th, let me know, because as much as anything, just so we can encourage you and look forward to hearing the pass report. So the good news is anybody who passes the CCNA by February 23rd is the last day to take it. You will be gifted. Gifted is a strong word, but your old CCNA will become the new CCNA. Whereas a lot of other certifications like the CCNA Security, CCNA Data Center, pretty much any CCNA other than, I think, CyberOps, one of them is staying. Maybe Industrial. I can't remember which one. I think it's CyberOps. But either way, pretty much all the CCNAs are going away. So if you pass, for example, if you were to pass the CCNA Security this week, you would keep it for 3 years, because Cisco's not yanking them away, but it's effectively a dead cert. It looks good on a resume, but you can do nothing to re-up it. So I'll stick around. Plus, yes, the training badges. The training badges are an interesting one, because right now they mean nothing. Cisco's going to dole out a bunch of training badges to people who have certs that are getting retired as sort of a consolation prize, I guess. And interesting, I learned this week, I didn't realize this, that my thought was, okay, so they're going to give a bunch of training badges away on February 24th. Is that it? Are we done? Can you go get training badges? And they said, well, the way they're doing that is they when you take official Cisco training, then you can get Cisco badges. So badges are supposed to show where you've put in the effort, where it hasn't necessarily translated over to a certification. So, all right, very good. It won't be a CCNA route switch. Okay, so Gus, you're saying CCNA CyberOps will remain. Thank you for confirming that. It won't be a CCNA route switch. It will be a CCNA with a training badge. Yes, I got to stop calling it the CCNA route switch. It is just the CCNA. Yeah. And if you have the old one, then you'll get the new one plus a route switch badge because they're getting rid of the route switch. Makes sense. Okay. Let's see here. Well, let's just go ahead and dive in. So this should do it. All right. Very good. So we're going to define subnetting first, just to make sure everybody's on the same page. So if you are, if you've already done some subnetting, then maybe this will be good review. But I just don't want to dive into the weeds before making sure that we're all caught up to speed. So what is subnetting? The idea of subnetting is taking a block of addresses and dividing it up into smaller blocks. Because when IP addresses were first created, and yeah, it's been, 30 years? I don't know. It's been a long time, but when they were first created, the blocks were predefined. And some of us, we've seen these before. We call them classes, right? So we had these classes defined, and class A was in the 1 to 127 range as far as what your IP address started with. So we think about an IP address as something like 10.1.1.17. I don't know. Something like that. So we have these 4 octets, and this first octet is what defined your class. So if the first octet started with a 1 or anything up to a 127, it was a class A. 128, actually technically 127 was reserved as well. So you could even argue that, whoops, I'm cutting the wrong stuff out here. You could even argue that this was a, if I erase this, I guess, there we go, 126. Come on, there we go. 127 is reserved. 128 up into 191, this was a class B, and then 192 to 223 was a class C. Now, we technically do have a class D, and that's the 224 range to 239. Oops. And then class E as well, 240 to 247 to 255. Sorry. I believe. I don't know. I don't spend a whole lot of time looking at class E addresses. So class D has been reserved for multicast. Anytime you're configuring multicast routing, you'll find these addresses, 224. If you study EIGRP or OSPF, you might find that they use multicast addresses and they start with 224, for example. So if you're doing multicast or anything that involves multicast, you'll see class D. But otherwise, within the world of unicast and within the world of typical IP addressing, we're talking about A, B, and C. E, by the way, is experimental and it's reserved and all that. Is 127 the only reserved range? To my knowledge, it is. I mean, again, this whole range here is reserved. I was trying to abbreviate reserved, and I might as well have just written it out at that point. But anyways, so it just depends on the. I don't know. I'd have to go look, honestly, to make sure that I didn't skip or I should have skipped 191 or something. I don't know. I'm just making it up. But anyways, star is reserved too, right? I don't know if that was automatically star. Is that like all 255s? Is that what you're saying? 127 is for the local addresses. Yeah, if you've ever seen, there's these great IT shirts that say there's no place like, then it gives 127.0.0.1. It's interesting because they reserved an entire class A range, which we're going to talk about here in a moment, how big these are. But this is a very sizable address range. It's pretty much reserved for local hosts. So for the most part, we don't see anything other than 127.0.0.1, which is always yourself. So if you ping 127.0.0.1, you'll always get a response because you're just pinging yourself. I love that shirt. Yeah, I know. I do too. I love seeing anything somewhat nerdy from a networking perspective. I've got one my wife bought me. It says, what does it say? I put the king in networking. And then, of course, networking ends with KING. And that part's like highlighted in red, so the king stands out in networking. I put the king in net. Anyways, I thought that was funny too. Okay, so back to subnetting. So these classes, in addition to, it just being a label, right? Because the label didn't mean a whole lot. It's simply like, oh, I've got a class A address, I got a class B address. It actually did have meaning in talking about how big the block size was. So we have these different, like class A, for example, class B, class C. The block sizes were, like the size of addresses were based on the position of the, it's based on the position of the subnet mask, but the subnet masks were defined and hard-coded according to these classes. All right, so I didn't explain that very well, but let me just start over. So the block size is determined by a subnet mask that is so let's say it's a /8, a /16, and a /24. These mapped to A, B, and C. And what the 8, 16, and 24 represent is how many bits in the IP address are hard locked and how many are not. So the more bits that are hard locked, the less bits you have that are free, because it's always a 32-bit address. And so the more that are, again, down here, when you have 24 bits locked, you don't have as many to play with yourself. But hey, a /8 right here has 24 bits to play with. So that's 2 to the 24, whatever that number is. I don't even know offhand. It's 2 to the 24 addresses that you got in a single block. So let's just give a couple examples. So in the class A range, we have I've already got one here, this 10. So 10.0.0.0 is kind of known as a private address range, which is true. Let's use a public address range. Let's call this, we'll just make it simple here. Call it 110.0.0.0. This being a /8 means that these first 8 bits are locked. So all of my addresses are going to start with 110. And then I get to play with all 24 of these bits. So that means that as long as I don't exceed 2 to the 24th number of devices I'm handing IP addresses out to, I'm good, right? I won't run out. And again, this is in the millions, if not billions. Let's just find this out real quick. I left my calculator. I know you guys can't see my calculator. All right, so 2 to the 24th power, 16 million addresses. All right, so we're up to 16 million addresses in a single block. And of course, early on, the naming authority, IANA, International Authority Naming Authority, something, International Address Naming Authority. I don't know what IANA stands for. IANA. They were the ones who handed out the addresses to the regional authorities, and the different regional authorities would then hand the IP addresses out. So, if you live in North America, you get the American version, which is ARIN, ARIN. And they would hand you, if you were early enough in the internet, they may be like, okay, you need IP addresses. I might have like a ton of computers, which back then might have been like 500 computers. Oh, we better give you a class A because you're going to grow. And say, give me 16 million addresses. You wonder why we're running out of IP addresses. This is part of the reason, right? So IANA, ARIN, all the regional authorities handing out addresses according to the block sizes because they couldn't carve them up any smaller than what the classes were predefined as. So this is class A. This is a lot of addresses. What are these other ones? So class B, for example, this, let's say, 131.20, I said 20, I wrote 10, .20.0.0/16. Well, again, these 16 bits, the first 2 octets are locked, which means I get to play with these. So that would be 2 to the 16th power. And 2 to the 16th power, let's find out what that is. 2 to the 16th, that should be 65,000, yeah. So that's the 65,536. So that got me 16 million, and this gives me 65K. Now, I know as humans, we don't do a very good job when you get into a ton of zeros, but there's a huge difference between 16 million and 65,000. So if you have a company that said, hey, I need to plan on growth for up to 150,000 hosts, boom, class A. Because 16 million is as small as I can get that still encompasses 150,000. And then class C, of course, we've got the /24 here. So let's say 200. I know I'm writing right over this. Let's go ahead and get rid of this so we can keep it consistent here. So 200.17.110.0/24 means that all three of those octets are frozen. I only get this to play with. That's 2 to the 8th, and I don't need a calculator to tell me that that's 256 addresses. So a huge difference between 16 million and 65,000, and then another huge difference between 65,000 and 256. Are we seeing the problem here? Our ability to break out addresses, it's truly like going to McDonald's and they'd be like, well, we've got a 2-ounce drink, we've got a 32-ounce drink, and we've got a 128-ounce drink. It's like, well, can I just have like a 16-ounce, like just something that's normal? And like, well, we've got teeny tiny, we've got very large, and we've got huge, and that's it. Those are only 3 options that we had before subnetting. Again, this concept of how many bits we get to play with was locked to the classes. This is called classful networking. Yes, all right. So catching up on the chat here. Sorry, guys, I got a little behind here. Big before VLSM. Yes, variable length subnet masking is what we're about to go into. That's VLSM. Anna, Internet Assigned Numbers Authority. Thank you, Gus. I appreciate that. There's always some acronym or something that I don't come prepared with. So I definitely appreciate when you guys chime in and help me out here. Hey, Nate, good to see you. It's been a while. Just got my CCNA certification in the mail. Thank you, Jeff, for your help. Wow. All right. Very good. Thank you for coming and telling me that. I mean, obviously, I can't necessarily, I don't know what happened to you. I haven't seen you for a while. So great success. Good job knocking that out before February. You're an inspiration to the people who are still trying to knock it out. So again, thank you very much for coming in and saying, hey. So, what's next, right? That's always the question, is what's next? Cisco's apocalypse is coming, but you've got your CCNA, so when's that CCNP, or when's that? Now I was going to say CCNA something, but there are no more CCNA specialists, so you got to pick that concentration exam and figure out where you're going to go next. All right. Incidentally, if we have time at the end of this, remind me if anybody's interested, and we can kind of talk about where the certifications are going. I'm not sure that we'll spend the whole hour and a half on subnetting, but I do tend to be long-winded, so we'll see. We might end up spending the entire time on subnetting. Okay, new page. So, Nate, well, I think I need some more experience before going into CCNP. Yeah, I appreciate that. There is such a thing as a paper tiger. You definitely don't want to just vault yourself into being more highly certified than your experience backs you up with. I had that problem early in my career. Just because I started working for a Cisco partner, I got a ton of Cisco experience up front. I ended up getting my CCNP by the time I had I was shy of 3 years in the industry when I got my NP. And then I got laid off. And so here I was, this is 2008, bad economy worldwide, right? I got laid off. I had 3 years of experience in a CCNP. That was hard to find a job. It really was. 25-year-old with, again, 3 years of experience out of school, CCNP. It's like, well, are you good at your job? Are you not good at your job? And so, yeah, that was tough even at 3 years. So, but either way, at the same time, I don't recommend slowing down. What I would recommend you look at is, you don't have to go all the way for the CCNP, but again, Cisco has those concentration exams. So start considering a few of those concentration exams, because those basically add the flavor to your CCNA. So if you've got your CCNA, come February 24th, you'll be granted the new CCNA. You'll have your route switch badge, but the badge is really not that helpful. So you go and take one of those concentrations, and now maybe you take a security exam, and now you've got a specialization in, and I don't know what the security ones are. Maybe it's like next generation firewall, right? So now you've got your CCNA with a specialization in next gen firewall, which would then of course allow you to pass the CCNP security with just one more exam, that security core exam. So that's the way. Again, we'll maybe get into that conversation later. All right, so enough stories. So where we go into now is this world, you guys already said it, variable length subnet masking, or VLSM. What VLSM grants us is the ability to control how many bits are locked out. So when we give an IP address such as 10.1.1.17, if this were classful networking, we would know that I've got one subnet here. Every IP address starts with 10, and everything is just in that subnet range. So I get one broadcast domain, one gigantic subnet. And VLSM came not only to help us solve the problem of having too many addresses being assigned, because that was certainly a big problem. Another big problem that was developing were these huge broadcast domains that were being developed. So a broadcast domain is just anything where all of the computers, all of the devices communicating with it, if they send a broadcast packet, everybody on the network is going to see that broadcast packet. And there's quite a bit of broadcast traffic that happens. So we don't want to trivialize that. And so when you've got, seriously, remember we were talking about 16 million? If you truly had 16 million devices attached to a single broadcast domain, nobody would have network access. It would just be, we'd be flooded with the broadcasts. And we've never had, I don't know what the largest subnet ever built was, but I'm guessing we've never had 16 million in broadcast domain. But as these were getting larger and larger, we needed a solution to be able to split those broadcast domains up. And unfortunately, we couldn't have a second broadcast domain without a second subnet, because I can't share a subnet between two different broadcast domains. Incidentally, these broadcast domains, by the way, these are what we call VLANs. So I could have two VLANs, but if I only have one IP address range, I can only put it into one of those VLANs. So where do I get another subnet for that second VLAN so I can split my hosts up and keep those broadcast domains small? Well, I'd have to go back to IANA and get another IP address range. So again, these are some of the problems that we're developing that VLSM is going to help us with. So what VLSM allows us to do, say, okay, you know what? You still own the 10.0.0.0/8 range, let's say. Again, this is a bad example because the 10 is a publicly available resource. So let's go back to that 110 we talked about. So let's say I own the 110.0.0.0.8 subnet range. Now I can control how many of these bits are locked out. As these are truly locked out, right? Like I only have those 24 bits still to play with. But now I can actually lock more bits and split them up effectively, split it into multiple networks or subnets within my own domain. So what that means is I could maybe say, I'm going to make the 110.1.0.0/16 and the 110.2.0.0/16 and all the way down to 110. I lost track of my thought here. 255.0.0/16. And there will be, technically I could start with the 0 as well, but there will be, if I use them all, 256 of these /16s. And that's if I only go down to /16. I could go further to say, I'm going to create a /24, a bunch of /24s. Well, that'll be 256 times 256, which is 65,000. So now all of a sudden I could create 65,000 Class Cs. And now we're starting to see where, that level of, remember how we talked about 16 million down to 256? Our brain can't process that sometimes, but there's truly 65,000 Class Cs inside one Class A, which is kind of nuts. So this is where we can now start to control that. So now I could take change colors here. I could take the .1, put it into this VLAN. I could take the .2 and put it into that VLAN. And I did that all with the range of addresses that I already own. So that's cool. We're still sticking with easy numbers, but as a lot of us know, we don't have to end on those octet boundaries. So we could actually throw a good old-fashioned, 10.1.17.0/ I'm just making something up off the top of my head, like a /18. Well, that's ugly because we know that at these boundaries, it's every multiple of 8. So we get 8 and 16 and 24. But /18 is somewhere in the middle of that 17. But hey, you know what? That's a legit technique, and we can certainly split our networks up that way. And we need to be ready because Cisco on that CCNA, they're going to ask us something like this. They are. And so we need to be able to start to carve these up. So what's expected of us as a network? Oh, hey, Nate, I just saw your note here. Thanks for the advice. We'll start looking at the concentration exams. Good. Hey, first of all, for what it's worth, take a break. You've got to take a breather. We all need rest. Rest is an important part of the cycle. So don't let me or anybody else tell you, all right, let's get on it, right? Get going. You need rest. You need that family time or whatever your situation is just to recoup. So recoup, rest, take a break, breathe easy. And, but yeah, eventually you'll get the bug and you'll get the itch to go start something else. And that's a good thing. Okay. So what is Cisco expecting us to know with these? Well, first of all, if we're given a subnet, they expect us to know the range. So again, we're talking about the first address in that subnet is this, the last address in that subnet is that. They expect us to be able to count the number of hosts that we have. So I already said, right, this concept of 16,065,256, we can get those pretty easily when it's the /8, 16, 24s. But what about a /18? How many hosts are in that range? And they might even ask how many subnets too. If they were to say, for example, you were given this 110.1.1. Well, technically this one, the /8, and you carve it up into /18s, how many subnets do you get? That's a legitimate question, right? We should be able to do that math and figure it out. They're going to want to know the, and this is kind of tied to the range and such, but they're going to want to know the network ID, which is the absolute first IP address in that subnet. Usually it ends with .0 or something along those lines. Something along those lines. That's not a good way of describing it. But in a lot of cases, it ended in 0. For example, all of these right here, the .0 address would be the network range, all of these that we provided, because that is the first IP address in that range. But then, of course, the last IP address is what we call the broadcast ID for that subnet. Oh, you know what? I'd gone and done it again, didn't I? All right, here, you know what? I'm going to rewrite this. Range, hosts, subnets. All right. Let's just do it over here. So range, number of hosts. I do tend to forget one of these times. Actually, I did it last week. I forgot to do it this week. I gave myself a little X down to the bottom right, so I knew not to write down there. And the, whoops, not the number. Get a little ahead of myself. The network ID and the broadcast ID. All right, we're going to try to get that going here. Give me an X so I won't forget. All right, big pop-up. IPv4, I've got no issue with. I take a minute extra for IPv6 subnetting. Yeah. Yeah, the IPv6, I mean, the techniques are the exact same, or I mean, the concepts are the exact same. In fact, it's arguably easier to subnet hexadecimal numbers because there is no concept of like the middle of 17. Every hex number represents so many bits, and so for the most part, unless you're truly getting granular, you're going to subnet between the hex characters, and the hex characters are it just automatically provides you a way to subnet at that point. However, what you do need to know for IPv6 subnetting, which we're not going to cover tonight, by the way, unfortunately we don't have time for it, but what we're not going to cover it, or what we need to know is some of the common subnets like /64, /48. We need to understand what some of those numbers are, but then also like FC0, is it FC/8, FE80, some of those common prefixes for different address types. So we have to understand that. There's not a ton of subnetting within the world of IPv6, at least from a real life perspective. Cisco might ask us a weird subnetting question on the exam, unfortunately. But for the most part, it's less about subnetting in IPv6 and more about memorizing those specific subnets, the subnets that we have to memorize. So global network range and link local addresses and things like that. Okay, so let's get to some actual subnetting. So I'm going to do two things here. I'm going to wipe the board, but I am going to try to give me at least, yeah, that's good enough. So that gives me an X that I know now, ideally, I know not to draw down there. So y'all can see what I'm trying to say. Okay. So subnetting example. Let's do this. 10.10.231.0 or, .1, I guess. We're going to do a /18. All right, so remember the things that we said that we need to know. We need to understand the range of this. We need to understand the first and last IP addresses in this range, potentially the number of subnets that we can get out of this. And a lot of our math is going to come down to understanding that we've got 32 bits in a subnet mask. And so, well, really, it's 1 to 32, I suppose. There's only 32 bits. And so when we're talking about 18 being in the middle, like right here in the middle is 16. And so we're 2 ticks to the right at 18. And we can start to use this to our advantage to start running some binary math. But before we start to get into that, we need to understand what the subnet mask is actually doing. All right, so because when we're talking about computers, we're talking about routers, we're talking about switches, layer 3 devices, etc. These machines are all binary. That's all they know and that's all they understand, which is why our IP addresses and everything in this industry is in binary. It's because it's what computers understand. And so what does a /18 mean? Well, what a /18 is saying is we want to take the IP address in binary, okay? So 00001010. That is binary for 10. That matches up to that octet. So next we have another 10. 00001010. Next we have 231. And we need to figure out what 231 is. How do we actually figure out what that is in binary? Well, we've got a technique for that, and I know unfortunately, we have to come back to this conversation because first of all, we have to figure out what 231 is in binary. So the way we do this is we've got 8 digits, 1, 2, 3, 4, 5, 6, 7, 8. Every one of these digits represents a power of 2. So 2 to the 0 power here, which means it's the ones, 0, 1, 2, 3, 4, 5, 6, and 2 to the 7 up here. 2 to the 7th power is 128. Okay, this whole process is exactly how our decimal system works. We're just thinking about, it feels more normal because we're talking about powers of 10. And that's fine. It's just that we have 10 fingers, and that's probably why we use the decimal system, is because at some point we realized, oh, we've got 10 fingers, and we started counting on them, and so everything is multiples of 10. If we had had just 2 stumps, maybe we would all be talking in binary. So it's the same. It's the exact same concept for how it all works. Big Papa, you've already got you've already got it figured out. I have to say, oh, okay, yeah, very good. I think 128, 192. Yeah, I'm gonna have to. Well, I'll tell you what. Rather than, because that's 7 plus 224. Yeah, that'd be right. Yep, I think you nailed it. So, ignoring the fact that the answer's already in chat, we got to figure this out. So how do we know what the binary is? Well, what we're going to do is we're going to find out whether there is, starting here from the left, can we take 128 out of our number? And we're going to do this iteratively. So we start with 231 and say, can we pull 128 out of 231? And the answer is yes, we can. And when we can, what we're going to find here, I'm going to erase the zeros. I'm going to change color too. What we're going to find is that we'll put a 1 in that place if we can subtract it out. Now, 231 minus 128 would be 103. All right. So next, 2 to the 6th power, this is 64. Can we pull 64 out of 103, and we can. So 64 minus these, this should be, you know, well, let's see here, 40, 39, I guess. So we should be at 39 now, and we put a 1 here. 2 to the 5 is 32. Can we pull 32 out? Yes. Okay, this math is getting easier now. So that's 7, we know. And so as we look at this, say, okay, well, 2 to the 4, that would be 16. I skipped 32 here. But we got 16. Can we pull 16 out of 7? No. So there's our first 0. The next would be 8. Can I pull 8 out of 7? No. That would be a 0. And then we keep going. Can I pull 4 out? Yes, I can pull 4 out. So 4 is, that would be 3. And then can I pull 2 out of 3? Yes. Can I pull 1 out of 1? Yes. So yeah, Big Papa nailed it. It's 3 1s, then 2 0s, then 3 1s. And that's it. That's how we figure it out. So coming back here to our operation, we'd say 1 1 1 0 0 1 1 1. And then what's the binary for 1? Well, fortunately, that's pretty easy. 0 0 0 0 0 0 0 1. All right, so we're getting a little tight here. Let me go ahead and erase some of this math so we can do our binary math now. So you do have to, if you're going for the CCNA, you've got to be rock solid with your binary numbers. I'm going to make some recommendations later for things that you should memorize. Big Papa, can I share a tip? Please, share away. We're all here to learn from each other. Okay, while he's doing that, so our subnet mask is also 32 bits. And so we called it a /8, remember, thinking that, hey, this, looking over here, we've actually got 18 out of our 32 bits. A subnet, what the subnet mask is saying, a /18, is saying that we've got a subnet mask that has 18 ones in a row. So we've got 8 there. 1, 2, 3, 4, 5, 6, 7, 8. We've got 8 there. That's 16, 17, 18. And then after that, it's all zeros. So the subnet mask is always a sequence. I don't know. Should I write all these? I'll write all of them. The subnet mask is always a sequence of all ones followed by all zeros. It has to be that way. All ones, all zeros. The subnet mask number tells us how many ones there are, and then the rest will be zeros afterwards. We can't interchange ones and zeros within a subnet mask. It can never be like 1 0 1 0 at the start. It's a sequence of contiguous ones followed by a sequence of contiguous zeros. All right, Big Papa says take the octet and subtract it from 255. That gives you the number to set to zeros. In this case, you get 24, which is 16 plus 8. So take the octet, subtract it from 255. So the 231 to 255 would be 24. That gives you the number to set to zeros. In this case, you get, oh, okay, so you're actually subtracting. That's clever. That's that you're going the opposite direction. So where we were adding all of the powers of 2, right? We were looking for the ones to figure out what added up to 231. Big Papa's saying, hey, you know what? We got 256 or 255. You make all of them ones. Now you basically work an inverse, and you say, okay, well, we're 24 short of 255. So let's make 24 in zeros effectively. So this 16 plus this 8 would be 0, 0, 0. So assumedly, if we picked 230, for example, it would be 25 short, and the 16 and the 8 wouldn't quite be enough. We'd also need the 1s bit here, so that would become a 0. So that's a cool technique. If you're closer to 255 than 0, then that probably makes sense to do. I think that's great. This is where, again, everybody's got their technique with subnetting. Okay, so what a subnet mask really means is the computers are going to look at the IP address and do an operational, like a binary operational operation. It's going to AND these two numbers together. Now, in the world of logic, what that says is if I have a 1 in either location, if I have a 1 in both locations, it's going to be 1. The AND operation is if I have a 1 and 1, then I get a 1. But if I have a 0 anywhere, 0 and 1, that's going to be a 0. A 1 and a 0 is 0, and a 0 and a 0. I hope I'm squeezing that in just barely, is a 0. So what we do is we look at this. We're not adding them. We're not literally saying, oh, 0 plus 1 is a 1. No. Quite the opposite. We have to do this logical math and do, again, an operational and on this and figure out where are there 1s on both sides. So where the 1s are on both sides, we're going to have a 1, like, for example, here and here and here and here. And everywhere else is going to have a 0. So as we do this, we can do some quick math here, quick analysis. 0, 0, 0, 0, 1, 0, 1, 0. 0, 0, 0, 0, 1, 0, 1, 0. Now what you'll notice is that this equals this. And that's effectively what an AND is. It's saying, okay, you know what, we're just going to take the bits that are up there and move them down. I mean, that's basically what this set of rules says. So if there's a 0 in either location or a 0 on top, we're taking it down. That's the subnet mask. And so over here then we get 2 more 1s. We get a 1 and a 1. Now because the subnet mask is 0 for the rest, and we know over here, again, I keep pointing over here, but we know anything with a 0 and it's going to end up with a 0, we've just got a lot of zeros. 0, 0, 0, 0, 0, 0, 0, 0. What the computer has done, what this binary operation has done, is it has given us the network ID. Okay, this mess of a binary set of numbers is our network. Remember we talked about that's one of the first things we need to figure out is what our network ID is. And so we've got to translate this back into decimal now because we're humans and we read in decimal. We don't read in binary like computers do. So these two numbers didn't change, 10 and 10. A bunch of zeros is just a 0. So the tricky part is always that middle number. I mean, that's usually where we're scratching our heads and trying to figure out what's going on here. And converting binary, we know this is the 128th bit. We know this is the 64, and 128 plus 64 is 192. So 192 is our answer, and this is the network ID for this /18 network. So write out prettier, 10.10.192.0/18. But unfortunately, we're not done. We've got a few things more to figure out. Here we got a little bit of chatter going here. Isn't that times? No, it's a binary AND operation. Yeah. Unfortunately, we can't simply. Oh, but star is analogous to and plus is to or. Oh, you're saying I should have done this with times symbol. It's been a long time since I've looked at logic gates, so I'm not exactly sure. I'm more used to coding where you've got the and operand, the ampersands, and the pipes for or. So I spend more time with that. It literally has been since college, I think, that I studied logical gates. So that's fair. You gotta go to small group. Keep up the great work. Hey, thanks, Nate. Thanks for stopping by, and thanks again. Congratulations. That's the biggest thing. Congrats on getting that. We'll still see you swing by every now and again. Okay. I was seeing it written instead of symbolic. Yeah, I mean, you can write. There's all kinds of. Then you get the logic gates, right? And so is it the rounded gate? Is it the triangular gate? And all of these is the triangular gate with a circle on it. And so it's a whole other world. Okay. So this whole binary process is. I mean, it's painful. It really is. This is why we need some shortcut techniques, and I know we're kind of building to it, but we are going to get to the shortcuts. Every time we subnet, fortunately, we do not have to do all of this binary math, but we have to understand that the binary math is happening, or we're just taking shortcuts. And taking a shortcut without understanding why it works is dangerous, because when we mess up, nothing's going to trigger us to understand that something maybe is off. Okay, so the next question is, we've got the network ID. What's that broadcast ID? Because that was the last IP address in the range. And all we're going to do is we are going to replace all of the zeros here with ones. Okay, and we have to be very careful about this because we're only replacing the zeros that aren't part of the subnet mask. So we happened to have, for example, in this case, a 1 and a 1. If we happen to have a 1 and a 0 here, because let's say this IP address up here was a 0. Okay, I'm going to change these back, but the point is, if there's a 0 there, we're not taking that one. We have to leave that one alone because it's protected by the subnet mask. Those extra 2 bits from the subnet mask. So I'm going to change these back, but know that we're not simply converting all of the zeros. We're only converting the zeros that aren't part of the subnet mask, that aren't being protected by it. So we change all of those to 1s. Now, when we do that math, none of this is going to change, and all of those are going to be 1s. Now, we can look at this and say, hey, this is a good example because those 2 are 1s. That just means we're going to have 16 1s in a row, because really it's the last 14. These 6 and these 8 all become 1s. But hey, when you take into account that there's 2 extra 1s over here, really it's 2 sets of 8 1s. So 8 1s is 255. We see that a lot in subnets, subnet masks, etc. Just binary operations, networking in general. So 10 and 10 didn't change. 10.10, those did not change. But hey, if we change all of those to 1s, it'll be 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1. That'll be 255.255. That is the broadcast address. And we do see a lot of 255s when we're talking about broadcast ranges or broadcast addresses. So that's a good tip that maybe we got it right. But it's not always the case. We have to be careful. All right. Now we just continue the list. We need to figure out what the first usable address is in this range. That's actually not a terrible operation. We simply say we take the network ID and we add 1. That's all it is. Okay, so the first address would be 10.10.192.0 plus 1. Okay, .1. And the last, this is really defining the range. The last would be the broadcast address minus 1. So 10.10.255.254. There we go. So we've got our range now. 192.1 to 255.254 is our range. Now we need to figure out how many hosts there are. Now, there's a couple of ways we could do this. We could truly start counting on our fingers and say, okay, well, there's 254 in that range, but then we've got to worry about 193 and 194 and all of that. And with a range this large, that's not particularly prudent. The easiest thing to do is to look at the fact that all of our hosts come from these 14 bits. Okay, now 14, we could count this out, but really it's just taking the subnet mask and realizing that comes out of 32 bits. And so however many bits are left is the answer. So 32 really minus 18 is 14. So we know there's 14 bits that define our host range. How many hosts can we have? Well, you'd think the answer would just be 2 to the 14th, because we've got 14 bits and they can all be 1 and they can all be 0. So 2 to the 14th. And that's really, really close. That is arguably correct. But one thing we have to keep in mind is that we've pulled the network address out and we've pulled the broadcast address out. And so the little trick here is you always have to subtract 2 afterwards. So if I pull up my calculator and I say we're going to do 2 to the 14, that would be 16,384. So 16,384, except I have to subtract those 2 that we can't use, the network address and the broadcast address. And so the answer here is really 16,382. That would be the answer. If Cisco asked this question on a CCNA exam, I guarantee you they'll have 382 and 384 there for you to have to pick between the 2. So, yeah, Big Papa, you got it. Want to make it. It might have already been asked, but can one NIC be on more subnets? Oh, can one NIC be on multiple subnets? Yes. The answer is yes, but it's easier to configure it to be on multiple subnets than to configure 2 NICs to be on the same subnet, because then you're usually talking about bonding in some way, and that gets really complicated. But if you just have 2 separate NICs in your Windows or Linux machine, and you're firing it up and you've got connectivity to 2 different subnets, then yes, that's actually pretty common, especially in the server world. One thing to keep in mind, and we don't think about this a whole lot, but every end device has a routing table on it. And most of the time it's, oh, you want to go out to the network. go out the NIC because I've got one path out. It's not much of a routing table. It's default route that way. So as soon as you have two different paths, your routing table gets a little more complicated, and you can no longer have a default route that is pointing out one interface. You're going to have figure out when you're using one over the other. And so, like, for example, in Windows, the most common situation would be I've got my wireless connected and my physical NIC connected. So I've got two separate subnets. Which one am I using? Well, Windows is going to try to figure out, based on the priority levels, and you can change that, which one is the priority. And it's going to set the default route to go out to that, even though you can actually go manually, if you wanted to, you can manually add routes to the routing table. So you can say, hey, if I'm accessing, I don't know, let's say I've got a NAS device here at my home. So I might say my default is the wireless, that's great, but hey, when I'm on the wire, I want to send my NAS traffic out the wired. I could use the wireless all day long, but send that NAS traffic out the wired. So I might make a route and insert it into my routing table to tell it to do that. That's two different NICs, though. Well, maybe I misunderstood the question then. You're saying, can one... Okay, yeah, I did misread that. I was thinking you were thinking, like, can one computer be on multiple subnets? Not one PC, but one network card. Okay, then no. I way misread your question. I apologize. I definitely read that as one PC having two NICs. One NIC cannot have more than one IP address on it. Oh boy. I mean, technically it can. Here's the weird thing. I'm not going to spend a whole lot of time on this, but like routers in the Cisco world, routers can have multiple IP addresses on one NIC. It's called a secondary IP address. And you can have as many secondary IP addresses as you want. So you have a primary IP address, and then you can have a list of secondaries. Now, whether you can do that on a PC or not, I mean, that's going to depend on your firmware. And there probably is firmware you can download for your NICs to allow you to do that. But the challenge with that is if you're truly on a single broadcast domain that supports multiple subnets, then whatever you're trying to talk to upstream has to have multiple NICs as well, right? Or multiple IP addresses as well. It's not a common situation for your PC to be doing that, but I've seen a lot of situations where we've had secondary IP addresses. A lot of times you're trying to migrate from one subnet to another, and so you put a secondary IP address in the same VLAN, and of course life happens and you never finish the migration, and so you've always got the secondary IP address there. So that's certainly an option in the Cisco world. I don't know. It's definitely not useful, even if you can put it onto your PC. Never thought about sub-interfaces on a PC. Router is a form of a PC. That's what I'm saying. It's possible. It's definitely doable, but you have to think about the implications of it as well. So, and there's a lot of implications. Okay, so we have done the painful version of this. Now, without further ado, 53 minutes into this stream, we're going to start to see how to do it a little bit faster. All right. Yeah, want to make no problem. And yeah, great question. So feel free to ask anything else that comes to mind. Okay, let's take that exact same IP address, which I already forget what it was. I ended up breaking from I think it wasn't it 10.10.231.1/18. Kind of this is just a .0/18. Okay, so there's this concept, and I didn't name this. Somebody else named it this way, but it's funny because as I was preparing for the CCNA, which has been 14 years now, 14 years, I noticed a pattern, and I kind of started to figure this out. And when I was doing some reading on it, I found out that, well, of course, you never invent anything, right? Somebody else had already thought of this, and they call it the magic number. I was like, well, okay, no, that actually helps a lot to put some concreteness around it. What the magic number is saying we're going to leverage our knowledge of binary. We're going to leverage our understanding of the fact that we have 32 bits in the subnet mask. All right. So what we're going to do, is we're going to say what I just realized this is a more complicated example than I wanted to start with. I was trying to decide if we should keep going, but let's just keep going with this because it's the one we just did. All right, what we need to do is we need to figure out which octet we're really dealing with, first of all. And in our case, 18, where, remember which bit number, where does that fall? Well, we know there's 8 here, we know it's 16 here, and we know 24 is here at these decimal points. So 18, the number 18 falls in this range between 16 and 24. So we're dealing with this third octet. And we can always, again, we're able to pretty easily figure out 3 of the octets at any given time. We know this is going to be 10.10.something.0 when we're trying to figure out what the range is. I shouldn't have called that a 0. This should be a 1 or a 11 or something. It doesn't really matter. Because we're taking an IP address and we're subnetting it, trying to figure out what its network is. So we know it's going to be 10.0 or 10.10.something.0. And so this is the number we want to focus on. Now, what we're going to do is we're going to count up from 18 to the next boundary. So we're starting on 18, and we're going to count up to 24. 18, 19, 20, 21, 22, 23, 24. 6 numbers. So 6 is our magic number. We'll come back to that because, you could think of 6 as a magic number, but we're also very interested in 2 to the 6th. So this is really, I shouldn't have called that the magic number. I believe, generally speaking, that this is your magic number, 64. So we're going to do several examples of this as well. So we're going to identify the octet that we care about, in our case, the third octet. We're going to count up to the next border, the next boundary, which we did. 18 to 24 is 6. And we're going to take 2 to the 6th power to get our magic number, which is 64. Okay. So now that we have our magic number, what we're going to find is that this 231 falls somewhere between a multiple of 64. So if we map out the multiples of 64, 0, 64, 128, 192, and 256. 231 is going to fall somewhere in there. And it's here. It's between 192 and 256. So 192, because we're going down, we always go down to find the network ID. 192 is the number that we care about. So the answer is 192. And that's it. We just figured it out. We just figured out the network ID by doing a quick operation. I mean, remember how long this took to get to 10.10.192.0. This is why we do not want to have to do this. We need a simpler method of figuring that out, and this is one of the ways. Now again, I go backwards. So in hindsight, I shouldn't have started with this example. This is a little bit of a complex one. So let's go ahead and we'll maybe come back to this, but let's do another example here. Let's do 10.1.1.45. And we'll do this as a /29. We like hanging out in this octet, I will say. We tend to like hanging out here because as soon as we move down an octet, it just makes figuring out host numbers and such a little bit more cumbersome. So this is why I wanted to start off with something we're here in the last octet. So again, knowing that this is the boundary, 24 is the boundary, 29 is higher than that. So we know we're dealing with this last octet here. So our network ID is going to be 10.1.1.something. Let's try to do this one a little bit faster. So we're going to count up to the next boundary. 29 to 32 is the next boundary. So that's a 3. And we take 2 to the third. So 2 to the third is 8. Here's our magic number, is the number 8. So now we look back at 45 and we figure out, okay, where does 45 fall between multiples of 8? And so we start doing multiples of 8 in our head. 0, you have to take 0 into account. 0, 8, 16, 24, 32, 40, 48. Okay, so between 40 and 48. So we go down a notch to say 40, because again, we go down in order to find the network ID. And by the way, the reason for that, just to be clear, is because the network ID is the first in the range. And so if I'm inside of a range, which I do this from your perspective, if you're inside a range, here's your range, well, you're going to go down to figure out what the first number is in the range. You're always going to go down because from here you count up. Okay, so I just want to be clear on that. So 10.1.1.40/29 is our network ID. That was pretty fast. All right, let's keep going with this exercise. So we need to figure out what the broadcast ID is, and we can actually use that 2 to the third, that 8 as well, because all we're going to do is we're going to add the magic number to, remember we've said it's between 40 and 48. We're going to take that 48 number and simply subtract 1. Because what this magic number represents is the number of bits within, the 8 doesn't represent the bits. This 3 represents the number of bits that we have to represent hosts. And so when we're talking about multiples of 8, what we're really saying is, okay, there are /29 subnets in this 10 range that one starts with .0, one starts with .8, one starts with .16, and we continue to go all the way down until we find that we're somewhere here between these two numbers. Well, if .48 starts the next range, well, that's not our broadcast ID. That's the start of the next range. That's somebody else's network ID. Well, the broadcast ID is bumped right up against it, right? Because my last number is going to be one less than their first number. So I simply subtract 1. All right, so I'm going to say 40 plus 8 minus 1 is 47. That's the broadcast ID. So what's my range? Well, my range, remember we got to do the add 1, subtract 1. So my range is 10.1.1.40 is my network. So I add 1, it's 41, through 10.1.1.47 is the broadcast. So I subtract 1 and say 46. So what's my number of hosts? Well, when it's this small, we can count 41, 42, 43, 44, 45, 46. Okay, 6 is my number of hosts, which is correct. It's 6. But technically what we always want to do, and this has nothing to do with the magic number, so it happens to line up with the magic number in this case because it's in the last octet, but if only works if it's in the last octet. So don't think about the magic number right now. Think about taking the subnet mask, comparing it to 32. So again, that's why it lines up with the magic number when it's in the last octet. But that 29 to 32, that's 2 to the third power. So 2 to the third power, that's 8. And what do we always do? We subtract 2. Because in our case, we're subtracting 40 and 47. 8 minus 2 is 6. Okay? So we've just figured out pretty much everything that Cisco could ask us. I will say this, they could potentially ask about number of subnets. Number of subnets always has to be relative to something, because I have, in the same way that I have 3 bits for hosts, I have 29 bits for my subnets. So the question is, how many, what are we comparing to here? Because I've only got one subnet starting with .40. But what they might say is, all right, so let's say you were given the 10.1.1.0/24 subnet, and they want you to carve it up into /29s. How many subnets can you carve that up into? Now that's a good question. I've got a /24. I'm trying to make the most out of my IP addresses. We're thinking about splitting it up into /28s or /29s. We're not sure. So how many subnets do I get by choosing one of those values? Okay. So if we're talking about a 29, carving 24s into 29s, well, what we're going to do is we're going to look at the delta between that. which is 5. Okay. So we've got 29 minus 24 is 5. Well, that's another power of 2 conversation. So 2 to the power of 5 is equal to 32. So I could get 32 subnets. Now, we don't actually have to subtract 2 because I can use the dot 0 and I can use the dot, whatever the last one is, dot 248 or whatever. I can use the front and last subnets. There's no reason to reserve those. So I get 32 subnets and I get 8 hosts. 8 minus 2 is 6. All right, Big Papa, yep, you got there fast. 2 to the 5. Usually they'll give you a network and ask how many subnets of a particular size you can get. Exactly. So in this case, they'd have to give you the network, this network ID, and then ask you how many /29s you can get out of that. So this would be the number of subnets. Again, when they ask for the number of subnets, it has to be relative to something. They can't just give you this 10.1.1.45 and say, how many subnets are there? Well, 1. You just gave me 1 subnet. How many /29s are in /24? Again, that's a really good question. Okay. Let's do another example. We got to keep doing examples. We got to keep getting practice with subnetting. Subnetting is just something you got to do a lot of. Okay. So I'm going to do something pretty similar. I'm going to say 10.1.1.68 and we'll do a /28. Oh, I lost my train of thought. We're going to do a /28. Oh, I remember now. I wasn't going to do slash notation. What I want to do is do a decimal notation. So subnet masks, we've been doing slash notation this whole time. How many bits are there? However, this range of zeros that we did a while back, I think it was here. Yeah, this range of zeros down here, all 32 of these, can be written out in decimal in the same way. Wait, right. I gotta get the right ones. Right here. This is the subnet mask. And even though we drew this out because we have, we knew we had 18 ones followed by 14 zeros. But again, we can write that out from a dotted decimal perspective. So what happens when we write that out? Well, what we've got is 255.255.255. And I was going to do a /28, right? So I'm going to do a .240, which should be a /28. All right. Sometimes you do these things off the cuff and you just got to double and triple check yourself. But so we've got this number. So how do we do the magic number now that we don't have slash notation? I mean, we could convert that to slash notation. I just said it's a /28. But there's actually an easier way to do this. We skip a step. This is actually easier to find the magic number. Rather than doing anything with a power of 2, we simply take that 256 number, which is call it the upper range, and we subtract the number that we care about, in this case 240. So we're going to get 16. That's our magic number. You know, if we'd had 28, if we were given /28, what were we going to do? Take 28 up to 32. That's 4. 2 to the 4th power is 16. So we get the same thing. It's just a little bit more of a straight up subtraction operation when we're given the dotted decimal version. So knowing that the number is 16, that's a magic number, we can look at 10.1.1.68, and ideally, you know, as you do more subnetting, you're going to get faster with this. So we think of multiples of 16. I could start with 0 and count up, but I might know at this point, I know 64 is a multiple of 16, right? 16 times 4. And if I had to count up 0, 16, 32, 48, 64, I get there eventually on my own. But I can sometimes look at that and just say, oh, 64 is the closest multiple of 16. So the network mask, or network ID, sorry, the network address is probably the better way of saying it, is 10.1.1.64, and this is a /28. And then the broadcast ID, remember what we're going to do, we're going to add the 16 to it, but adding the 16 takes us to the next network, so we got to subtract that one. So 64 plus 16, 80. So we'll subtract 1, 10.1.1.79. That would be the broadcast. The range, we can see this starts to get fairly straightforward. 10.1.1. We're going to start with 64 and add 1, so we'll say 65. And that goes until the broadcast range, minus 1, 10.1.1.78. As far as the number of hosts are concerned, again, we can do that math in our head, but really we're going to do the, well, I guess in this case, subtract 255 or 256 rather from 240, other way around. Anyways, however you want to do it, either way, it's 16 minus 2, so the number of hosts would be 16 minus 2, which is 14, is our answer. If we had to find out number of subnets, quick example of that. So if we said number of subnets, and let's say in our case, again, it has to be relative to something. So let's say we were given the /24, 10.1.1.0/24. How many /28s are there in a /24? We're going to, again, do the delta. So we're going to look at 24 and 28. That's 4. 2 to the 4 is 16. So that's it. That's all there is to it. There's 4 bits through 24 to 28, and so 2 to the 4, which is 16. That's how many subnets that we can get. Whew. Okay. I want to do one more example of a, but it's a little more fun, like I said, to operate in the last octet. Let's do the third octet or the second octet. In fact, if you have a good, give me a good one. Give me something good that we can go through together. So chime in with the chat and give me a good range. We'll do it right after this. So let's say I've got a 131 dot, this is dangerous, I'm just making this up as I go, 86.1.1, and this is a /14, I guess. Let's do a /12. Make it more fun, I guess. All right. So first of all, the part that we've skipped over a little bit is we have to figure out which octet is interesting. Okay. So we know, again, identify the boundaries, 8, 16, 24. This is something that you'll start doing in your head super fast if you're not already doing it. We know that the interesting octet is between 8 and 16, so it's this octet. So we can right away move the other numbers down. When we're talking about our network ID, it's going to be 131 dot something dot, well, we can't actually move those down. There's actually going to be zeros. So it's bad. I think I said at one point you move them down, but really everything becomes zeros. Remember our earlier binary conversation. All right, so what is going on inside of that octet? Well, we're going to do our magic number operation, and the way we do that is we find the next boundary marker. So we're going from a 12 to a 16. So 12 to 16 is 4, right? You just subtract. 16 minus 12 is 4. And so 2 to the 4 equals 16. 16 is our magic number. Okay, well, we're going to do the exact same thing. 86 belongs between two multiples of 16. Me randomly making up numbers, this is going to be this. Oh, no, it's not the same. Okay, I was like, it's the same as before. We ended up with 16, but that was between 64 and 80. Well, now we're, again, I'm getting used to this. Okay, I know 80 is a multiple of 16, and I know 96 is a multiple of 16. But if we have to, this is a maybe lower. If this was like a 137, I might have to count that out. I know 16 times 10 is 160, so I know 160 is a multiple of 16. I might have to work my way backwards in that case. So, tell you what, let's have some fun. Let's make this 186. 186. Yeah, I don't know my multiples of 16 super well. Not well enough to immediately know what the multiple is. So like I said, what I just say, right? 16 times 10, I know 16 times 10 is a multiple. So let's say 160, let's just figure this out. 176, 192, and 208. Okay, those are multiples of 16. 186 falls right smack here in the middle. So 176 would be my number. Now, if you already figured out on your own, sorry for throwing the curveball. If you're already doing 86, then .80 was the number, right? .80 would be the lower number. But going with the 186 example, 176 would be our number. Okay, so this is where things start to get a little bit different because we're no longer in the last octet. Okay, we need to figure out what the broadcast ID is. And the broadcast ID is going to be 131. And then we come to the interesting octet, and we got to figure out what our uppermost number is. Now we end up doing the exact same thing actually. We take our 16, we add it, so 176 plus 16 was 192, and we subtract 1. So 191. But what do we do with these other numbers? Well, technically what we're doing is we're taking 192.0.0. We had the 131 over here. So we're taking this is the part we care about, and we're subtracting 1. Well, what happens when you take 1 out of 1,000? Well, you drop the the leading number, and you roll all the zeros back, right? You just roll them all back to 9s, so it's 999. We're going to do the same thing here in this operation. By rolling back, we're going to drop this to 191, and these zeros roll back to 255. So this answer here, the broadcast is going to be .255.255, which again, like we said earlier, if you see 255 in the broadcast, you're usually in good shape. 131.192 is the next network ID, right? Yeah, that would be the next network ID. So we have to subtract back. Okay, so now we figure out the range. Again, it's a little bit different. We're not in the last octet anymore. So the range is going to be this 131.176.0. Well, we add 1, right? We just add 1 to a bunch of zeros. It's just going to be .1. That part's not too bad. Through 131. Remember, we start with the broadcast and we subtract 1. .191.255.254 because we subtract 1. Okay, this is good. This is really good. Now for the number of hosts. This is probably the most different part of this. If we did what I was saying, this is the warning I gave earlier, and it probably didn't make as much sense. But if I just look at my magic number and say, hey, I remember, we did these examples. They were always in the last octet. But hey, this 16, I know I take 16, I subtract 2, it's 14. No. This is why we don't pay attention to the magic number inside the host count. Again, we could try to count in here if we have enough fingers to count, if we can count in binary on our fingers. I saw somebody count in binary on their fingers. I don't know if anybody watches or plays Super Smash Brothers, but Nintendo put out this, as part of this video game, this video, and the creator of this video game is sitting there counting in binary on his fingers. He's going like 1, 2, 3, but you get to 4, and it's not a great number to count on your fingers. Figure it out why, but anyways, so if you gotta count on your fingers in binary, you might be able to figure it out. Either way, what we're going to do is we're going to compare the subnet mask to the number 32 because that's the max. So in this case, it's 20. So we'd say 2 to the 20 minus 2, whatever that is. It's going to be a monstrous number. Whew. So that's the number of hosts. If they were to say something like, how many /12s could you get out of a /8? Let's do the number of subnets. So they said, you get a /8. How many /12s can you do? Well, /12 compared to a /8 is 12 minus 8 is 4. So we're going to do 2 to the 4, and that's 16. Okay. So the number of subnets would be 16 in this case, versus the number of hosts. All right, 20 bits, LOL. Yeah. Yeah, there's a lot of hosts in that range. So, yeah, there we go. So this was a little more complicated example. You can see the magic number concept is intended to just speed up your operation. If you don't understand what's happening underneath the hood from the binary counting perspective, then be careful with trying to shortcut it. Until you're comfortable with what it's doing, you You don't have to be super fast with the binary. I'm not saying like don't do this until you can do the binary operation in like 30 seconds. I'm not saying that at all. The binary operation is going to take a while. But if you can't do it with binary, then don't do the magic number yet. Once you can do it in binary, once you understand what it's doing and what these bits really represent, then start looking at this magic number concept. I will tell you this, just to advocate for it, this is how I do subnetting in my head. I can do it very, very quickly. Somebody gives me a subnet, as long as it's not one of these ridiculous 131.186s. When you're talking about in real life, most of your subnets are /24s or north of /24s rather. So like a /25, a /27, /29, something like that. Those you can start to do pretty fast. So anyways, just keep that in mind. Know why the shortcut works before you use the shortcut. I 100% agree, Big Papa. All right, so couple more things before we wrap up. First of all, what to memorize. I highly recommend, let me just write this out. So what to memorize. As you progress in your networking journey, I highly recommend you memorize 0 through 15 in binary. What do I mean by that? I mean I mean being able to look at a sequence of 4 binary numbers, so basically 0010 or something like that. Being able to look at that and by its pattern know what it is. So if it's 1101, you know that that's 13. Okay? And you don't have to sit there and add 8 plus 4 plus 1. Okay? And so what I would recommend doing is just sit down and write them all out. 0001, 0010, 0011, and try to get to a point you can look at these numbers and memorize them. The reason for this is because there's going to be, when you're subnetting and such, a lot of times you end up splitting down the middle, like again, some of those /28s and such, and you end up with a string of 4 binary digits. And even if you end up with a 5th, if you can read the first 4, you can just look at those 4. Basically what it does is it speeds you up from having to add those numbers together. So let's just say 1001, this is 9, okay? If I see a 1001 and it's got a 1 in front of it, well, I know that 1 is the 16s column, so I can just be like, oh, that's 16 plus 9. So hopefully I can get to the fact that that's 25 pretty quickly. Or maybe a 1 and a 0. Well, I have to kind of stretch it out there, but hey, that's a 32 plus 9, so that's 41. I can get really fast at reading binary if I have those last 4 roughly memorized. Here's the good news on memorizing binary strings. It sounds pretty rough and boring, especially if you've just started this world. Pattern recognition really helps. Again, this 1001 is a palindrome, right? It's front and forward and backward. You can that's just a pattern. You don't have to look at that and do math in your head. Just know 1001 is 9. Here's my favorite. You know what 1010 is? Give you one guess. It's 10. It's 8 plus 2. It's right there. So if you see 1010, you know it's 10. Here's another fun one. What do you think 1011 is? It's 11. So these aren't too bad once you start to recognize the sequences. Honestly, the hardest ones for me when I'm just looking at them is when I see 10 and 100 and 1000. Because I have to stop and think, like, wait a second, okay. It seems wrong that 100 is 4 because it just, I don't know why, it just doesn't quite sit right with me. Like 101 I know is 5, but like 100, it's like, is that, okay, yes, that's 4. Once you recognize 0 to 15, you can convert to hex very easily. Thank you, Big Papa. Yeah, I was just about to mention that as well. We talked about, remember earlier we mentioned for those who were here for the IPv6 conversation, that uses hexadecimal. And what's hex? Hex is simply taking 0 through 15 and replacing that with 0 through F. 0 through 9, A, B, C, D, E, F. And so we're assigning now, instead of 10, this would be hex for A. 11 would be hex for B. 12 would be hex for C. And we just can keep the process going here. And so once you have these memorized, you can subnet, especially again, this is where the hex concept really helps. with IPv6. Unfortunately, I don't have hex and IPv4, so it is what it is. So memorize 0 to 15 in binary. That's number one. Number two is what I would recommend. Boy, that was the worst little. I tried to do one and circle it. There we go. Number two, what I would recommend you memorize is this string of numbers: 128, 192, 224, 240, 248, 252, 254, and 255. And I wrote that out that way on purpose. Why memorize these? Do you remember earlier when I was converting, I was like, this is a /28. And then I was like, I think that's a 240. Yeah, that should be a 240. These are within one of those octets. These are the only valid numbers that a subnet mask can be besides having a 0 there. So if you have, for example, a .128, that would be a /25 or a /17, right? It's the first number after a 0. So if it goes from 0 as a /16, right? If I had like 192.168. I forget what I was going to do here. 0.0. And then 255.255.128.0. Well, I can like use these sequences of numbers to try to convert back and forth between slash notation and dotted decimal. So the .128, I should be able to say, I know there's 16 bits here, and because I know 128 is the first option, I just add 1. So what if, for example, we gave that, let's say it's 248.0. What's the slash notation for this? Well, if I have this sequence memorized, and know, by the way, again, I wrote this way on purpose with the division here. Know these 4, and then know these 4, and that'll help you kind of figure it out. It's right in the middle. If it's a slash, well, that would be off of the 16, so I'd be halfway up. That'd be a /20, right? Because /16 is 0, so this is 17, 18, 19, and 20. So it's less about like memorizing that 240 equals a certain thing, because you can't do that. It's just have it in your head, 2 groups of 4, and have these numbers ready, because that'll help you convert again between the slash and the dotted decimal. All right, want to mech? Sorry, like, do you want a mech? Is that what you want? I like the name. There was a nice Android game, can't recall its name, but you needed to flick bits to get the numbers written in decimal. Can't remember its name. Yeah. But I bet there's a lot of these out there. It's called the binary game, Gus. Thank you for sharing. Yeah, there are a ton of subnetting, binary. I mean, gosh, just go out on iOS or Android. Just look at the market. You'll find all kinds of games out there to help you with it. And when it comes to memorization, right? I mean, memorization is just, you got to see it. You got to keep seeing it. Got to keep seeing it. All right. Let's go with, I said if we'd have time, I'd comment on the Cisco certs, but we really only have 2 minutes. I'll give you the 2-minute version of Cisco certs, and then we'll call it a night. So the way Cisco is doing their certifications now, I think is really cool. I actually really do. I'm really excited for this. The way they're doing it is, as we know, the CCENT, it used to be this: CCENT, CCNA, CCNP, CCIE. And there still are multiple disciplines in this, but what Cisco's doing is they're getting rid of the CCENT. And the interesting thing about the CCNA and CCNP is that, like, let's say you got the CCNP security or the CCNA security. You were expected to know everything about security because you're a CCNP security, right? I mean, you must know everything about it. And the hard thing is that to pass the CCNP, you did have to know almost everything about security. That means next generation firewalls. That means email and web filtering. That means I just said email and web filtering. What's another one? Intrusion prevention systems, ICE, right? Identity services engine. There are a ton of content and topics within the world of security. However, the only option in the Cisco cert world used to be that if you could get a CCNA security or a CCNP security, and no matter what, it just meant that you were either pretty darn good with security, that's the CCNA, you're pretty darn good with security, or you're really darn good with security. Or of course CCIE, which hasn't changed, is you're the foremost expert on all security products. But either way, you know every product that Cisco makes within the security world is within that. And the problem with that should be pretty straightforward, which is that, look, I mean, I'm a data center guy, but when it comes to data center, I'm really, really good with the data center networking. I'm really, really good with Cisco UCS. I'm really, really good with fiber channel. If you want me to configure your rack mount servers, if you want me to configure your storage array, if you want me to configure your virtualization, your hypervisor, you might want to find somebody else. Because I'm just not good at those. I've spent most of my time on the networking and on the UCS stuff. And so the cool thing about what they're doing here is they're changing this model to say, okay, there's no CCENT, so there's one CCNA, and then we have concentration exams, they're called. These concentration exams effectively equate to a specialization. The specialization is within a field of, for example, security or a data center. I know the data center, so I'll use that as the example now. So there is now an ACI concentration. I can go add an ACI specialization. I know it seems like I'm interchanging the words, but the exams are the concentration exams. When you pass an exam, you get a specialization. It's unfortunate. But either way, I can go get the specialization in ACI. I can get that as a CCNA. I don't have to get a CCNP anymore. And Cisco technically wants me to do this. This is the path that they recommend, I think. At least it seems like that in some of the stuff I've seen. But what this means is I can't go get a CCNA in data center anymore. Okay? Which I have. I mean, I'm a data center guy. Like I said, I'd go get that CCNA in data center. But what I can do is say, you know what? I'm a CCNA with a specialization in ACI. That means that it means more than a CCNA data center. CCNA data center told you that I know about data center stuff, but you would never know that, okay, Jeff, you're good with Cisco networking in the data center. You're not good at storage arrays, right? You wouldn't know that. But this new methodology tells us that. Security, think about the same way. Like maybe you're really good at next generation firewalls. Maybe you've never touched ICE. Okay? So those are the kinds, this is the concept that Cisco has built these certifications around, which is really great. So now I'm a CCNA with an ACI specialization or what have you. Now that I have a data center this is a data center specialization, right? Now that I have a data center specialization, I can go pass the data center core exam, and that gets me not only a CCNP in data center, which is very cool, but it also allows me to go take the CCIE lab. They got rid of the CCIE written. So that DC core is truly just the next step to get, or it not only gets me the CCNP, but it's the next step towards CCIE if I'm interested in that. I love this because the CCIE journey is very awkward around the lab because you almost have to study for, the written. You almost have to study for the written separately and then take a break and then go past the lab. Like the people I've known who have tried to do it all at once, most of them haven't succeeded in that. So like you almost have to do them separately. So I love the fact that you can prove that you're an expert at this or a professional level, and then that opens you up to go take the lab to pass the CCIE. Okay. So if I do then go get my data center core exam, I'm a CCNP data center and I still have that ACI specialization. And then let's say I want to get another specialization. Let's say I want to go get a specialization in data center design. I believe there's a data center design concentration exam, so I could go get that. And so now you're going to find that I'm a CCNP data center with an ACI specialization and a design specialization. Okay? That's the idea. This is the new world of Cisco certifications. So going after your CCNP is going to be get that CCNA, get a specialization under your belt, and then go get that core exam. Now, you can flip this order. You can go get the core exam and then go get a specialization if you want, and that's fine. You can do that. But it's kind of in that order of operations where if you get the specialization, at least you've got that. You pass one exam, you've got something to show for it. If you truly just go and pass the DC core, you don't have anything to put on your resume. You don't have an NP data center, you don't have a specialization. So I would recommend, in most cases, probably doing the specialization before you go take the core exam, which will be more comprehensive, by the way. There will be more of a little bit of everything in the core exam. All of them, security, enterprise networking, data center, unified, what they're calling collaboration these days, right? Which was voice, and now it's voice, video, and unified messaging and things like that. So all of them are built this way. So if you feel like you're being called towards security, if you feel like you're being called towards collaboration, or if you're after my own heart, you're going after data center, then either way, you kind of pick your specializations and go. But the cool thing about this is I could go get a specialization maybe in next generation firewalls, and maybe I'm a data center guy, but hey, you know what? I've got a specialization in those next generation firewalls. I'm not CCNP security, but I've got a specialization. So it allows us to number one, to specialize, but it also, number two, it allows us to not commit to going the full way and just sort of, this is the equivalent of the CCNA level certs. I'd have no choice but to go get the CCNA security if I wanted anything security, but with the new world, I can go get a security specialization. All right, Big Papa, is it a DC core? I thought the concentrations passed upwards from CCNA, CCNP, but you had to take the on-core for the CCNP. Yes, I think what you're asking is there a DC core? I thought the concentrations passed upwards from CCNA. They do. Not sure what you mean by pass upwards. But I think is it a DC core? The encore exam, okay, let's just be really clear about this. Okay. The CCNA is here. If you want to go, let's say there's an enterprise networking path, there's a data center path, there's a security path, there's a collaboration path, and here's the concentration exams. And so we've got like 5 enterprise networking concentration exams. We've got, let's say, 5 of each at this point. There's different numbers of these. I just don't have them memorized. So there's concentration. So I get the CCNA, then I go get any number of these specializations. I could get them all if I want. I mean, if you really wanted to get them all, I'm sure somebody will collect them all. I don't advise that. But you go get that, and then all of these have a core exam. So I know it's on-core, I know it's DC core. I don't know what these are. I assume it's something like set core. Maybe it's SECOR. I have no idea. Collab core, whatever that is. Collab core. I don't know. That's not even the right number of L's. So whatever this is, there's a core exam for each of these. And then this is what allows me to go take that CCIE lab for that specific discipline. So if I pass the data center core, for example, I could go take the CCIE data center lab. If I pass the enterprise core, I can't spell and talk at the same time apparently. If I go past the encore, if I take this path, I get a specialization, I come up, I pass the enterprise networking core or encore, then I can go take the CCIE lab for enterprise networking. Big Pop, okay, it was the different core exams I was stuck on. I guess it shows which way I was headed. Yeah, going on Encore. We had CBT Nuggets. We're trying to crank out Encore. We know that, our priority was certainly getting out CCNA. Keith Barker, Jeremy Chara, Chuck Keith, or Network Chuck, put together all of the CCNA content. And so that's phenomenal content. If you have a CBT Nugget subscription, be sure to pull that up as you're preparing for the exam, if indeed you're still preparing. But yes, I recorded Nuggets today for Encore. Our priority is to get Encore out as soon as possible. So we'll hopefully have some timeline updates as we get closer to when that exam is coming. I will tell you, it won't be done by like the day Encore releases, but hopefully within a good time frame after that, we'll be getting it out there. We want to get everybody enabled in this new world to go out and get these certifications. Once Encore's done, I'm probably going to go start working on DC core content, because that's what I love, or maybe one of the specializations. But boy, there's a ton of content out there that we all need. So there will be no end of recording nuggets for us anytime soon. All right, everybody. Well, I've talked until my throat's dry. Went a little bit over. Thanks for sticking with us. Hopefully that was useful. Be sure to come back next week. We're going to do our review time. So we've gone through all of the CCNA content. We spent a week on subnetting. Next week, we're going to have some fun. I'm going to, I've got some plans in place. It should just be a fun time for us to get together and do some review together. Hopefully make it interactive as much as possible. Feel free to bring questions. If you got some questions, bring them. And I'd really rather be directly useful to you than to just go over things that I want to review. But as we as we kind of get closer and closer to that February 24th date, I know that a lot of people in the audience are working towards passing by then. So hopefully it'll be a good time, if nothing else, just to kind of hang out. Quick to the chat. I'm not going to start working out right away. Okay. Yeah. You need to take a break. Once you pass the CCNA, like I told Nate earlier, take a break. Absolutely take a break. I've never passed an exam and gone right to the next. Well, not an exam. I've never gotten a cert and gone right to the next one. Always take a break. Always rest. You'll burn out going one way. If you take that rest, you'll eventually get that itch to go back, and then you're attacking the next cert with passion. So 100% agree with that. More birthday wishes. Thank you, everybody. Julio, thanks for joining us. It was a lot of fun. I love this. Having a great time hanging out. So thank you very much, everybody, for joining me on my birthday for some birthday subnetting. And again, we'll be reviewing next week. So everybody take care, and we'll see you next time.